see what D is. And it says use the information from these other parts to sketch the graph. That's such a horrible request to make on a person, but let's see if we can do it. So let me draw some axes. Alright, so there is a y-axis, and I'll make the x-axis the same as this line. Okay, so let's call this, I don't want to get too crazy, let's call this 2 pi. Let's call this minus 2 pi. Alright, and so what do we know? Let's recall what we learned from these other questions. We know that the function is increasing everywhere. But let's be a little bit sensitive to what we learned about the first derivative. So when we looked at the first derivative, we saw that it was positive everywhere, but it does have little flat places, right? Like right here it's 0. So what this is going to look like for the function is it's increasing, and what's its concavity going to be on this first part? So in this first little part, from negative 2 pi to, maybe I should write down all the significant points, huh? That would be a good thing to do. Let me go down here, and so let me make a little notch at minus 3 pi over 2, and a little notch here at minus pi over 2, and a little place here at pi over 2, and a little place at 3 pi over 2. Alright, and so maybe I should use my colors here to help me draw the picture. So what I'm going to do is I'm going to make a little magenta interval where it is cup up. Okay, it's going to be concave up on this part, and I'm just reading these things that I wrote right here. It says right here that it's going to be concave up there. Let's just make sure that I wasn't having a fit of insanity. Yes, it's true. And it's going to be concave up on this part. Okay, and I'll make a little legend for my thing here. Okay, so we're going to call magenta cup up. Okay, and it's going to be concave down on those other places. So what else do we care about? We care about, normally I would indicate where it's increasing, decreasing, but we know that it's increasing everywhere. But even though it's increasing everywhere, it still has these little flat places. Okay, so what does this mean? At first it's going to be cup down, and then it's going to have a little flat place, and then it's going to be cup up. Okay, so this is both an inflection point and a critical point. Okay. All right. So what are the roots of the derivative? They are negative 3 pi over 2 and pi over 2. Okay, so I have to keep in mind that the first derivative is going to be 0 there, even though the first derivative doesn't change sign. So let me just make a little mark for those. Okay, so I'll use this ugly orange color. All right, so this is going to be root of the derivative, and this is also going to be root of the derivative. Okay. All right. All right, so I need to know where to start, and what happens if I plug in negative pi over 2? I'm going to get, if I plug negative pi over 2 in here, that's going to tell me where to put my pen down, and that will give me negative, I'm sorry, I don't know why I'm saying pi over 2. I mean negative 2 pi plus cosine of minus 2 pi. And so what is this? This is negative 2 pi plus 1. Okay? So that's where the graph is going to begin. So that's where I'm going to put my pen down here. It's negative 2 pi plus 1. So let's just say that that's here. Okay, and now what's happening is, remember on the black places it's concave down. So it's concave down. Then it's going to get to this first place where its first derivative is 0, and it's going to be flat for a split second. Okay, and now it's still increasing, but now it switches to cup up, right? Until it gets here, it has an inflection point. We should also, I'm going to need to know what the y-intercept is, right? So what's the y-intercept? Remember, the function is t plus cosine t. So what happens when I plug in 0? I get 0 plus cosine t, cosine 0, so this is going to be 1. Right, so I have a date with the y-axis here, at the y-intercept. Okay, so I have an inflection point here, and I hope my hand stays steady enough to do the picture. Alright, and now another little flat place. Okay, so these orange balls are telling me to make a flat place because there's a root of the first derivative there. And now look, we've come to a little magenta interval, so that means it switches to concave up. Okay, so it switches to concave up for a while. Okay, but then when the concave upness is over, we have to do an inflection point, and it becomes concave down, even though it's still increasing, and now it's concave down. And that's where we finish. Okay, so that's 2 pi plus 1, right? 2 pi plus 1 is this stopping place. So y equals 2 pi plus 1. And we have finished the picture. This is what the function looks like on that interval. And thanks for bearing with me on that long, hard problem.